Dr. Girisha Garg, and I'm with the Amazon TNC team. Today, we will be talking about machine learning basics. And with me, I have my very distinguished colleague, Dr. Anil. Dr. Anil, would you like to start the session?
Yes, Grisha. Thanks for the introductions. I'm Dr. Anil Kumargiri. I work with the TNC team, AWS, and I'm technical trainer. Especially, I take the DevOps operations. So, thank you guys for the joining. And Grisha, you may start. Thank you for your kind, the introductions.
Thank you, Dr. Anil. So I see we do have a lot of participants today. It's really encouraging to see all of you participating in this session. I appreciate you spending your time with us. Now, let's discuss where are we standing in terms of machine learning basics today. So the expectation from this session will be probably to get you accustomed with the machine learning terms and technologies and jargons so that whenever you are ready to start your machine learning journey, and if you're already on that path, you can enhance that from this session. Also, this will help you to accelerate your learning so that now you can understand a few basics much more clearly and with a more depth concepts. So this is the expectation from this session on the basics of machine learning. Let's get started. So before we get our journey on machine learning basics today for 1.5 hour session, we will be starting with a very basic example of recommendation system. Now, I'm sure you guys must have gone through lots of recommendations from the sites all over these days. So the sites vary from the e-commerce sites, the media sites, and then you have Coursera. Not only that, even if these days, even if you type a mail on your Gmail, message on your Gmail, write down a mail, you are recommended by the process what you would be typing or what you would want to type. So these are all different type of recommendation systems that are really happening these days and which are very, very effective. Now let's suppose that we have a business need in which an e-commerce site has to provide recommendations for the products to the customers, and that has to be on the basis of past purchases. I'm sure you all must have been realizing this and experiencing this particular concept in your daily lives. How could I solve this problem using the classical programming approach? Can I solve this using classical programming approach? Definitely, yes. This was how it was done some time back when we did not have the machine learning approach or the deep learning approaches. It was actually solved using the classical programming approach. So what was used to be done at that time was we used to have all the purchase history with us for all the customers. Let's say currently we have 492 participants today. What if I collected all your responses and put it into one particular storage and I have all the histories, right? What I could really do is define a rule-based system for myself as a programmer. And on the basis of these two things, I will start making recommendation to the customers. Now, I see a very, very big problem here with the classical programming approach. I'm sure you also would do. First thing is I have to create these rules, which can be a very lengthy and very difficult process because it's very difficult to gauge human relationships and human choices. It's very difficult to do that first. Second, as we keep on adding rules, the system becomes more and more complicated. Not only that, as more the rules, more the time taken to give an output. For example, if you went on a particular website and you bought an iPhone, and immediately you usually get a recommendation for a cover or maybe a screen guard, something like that. What if that recommendation came in after few minutes? There might be a possibility that you would have logged out of the system, isn't it? Right? Also, there might be a possibility that you would be disinterested in that. So basically, in both of these cases, if I'm taking time to, let's say, give a recommendation, I'm losing my customer, right? So I do not want that. As a business owner, I really do not want that. So this is where I'm losing my customer and my business. I would not like that. So what I really want to do is I want something which can enhance this approach. Can we do it? Definitely yes. So what is the solution? The solution is a machine learning approach rather. How would this work? Let's discuss this. So when we are talking about the machine learning approach, the rules that I was designing earlier, that rule base will now be designed by the model. I would not be designing the rule. The model will be designing the rules for me. The data will still come inside the similarly. I still have the purchase history and I still have the site-wide customer data. I will combine this particular thing given to the model. It will give the rule base to me. This rule base will be now the model's responsibility, right? I will combine this with my most recent purchase and I'll start making recommendation to the customer. What do I gain here? Let's try to understand that. What am I gaining when I'm using a machine learning approach? The first, as I said, the data will be just one thing that you will be giving and model will be defining the rules themselves. And since it's an adaptive process, the customer profile, however complex they are, it's easier. I will not say it's absolutely perfect, but it's much more easier as compared to the profiling in case of a classical programming approach. And the third flaw that I was seeing in the classical programming approach was as I kept on increasing the number of rules, I was losing time and the customer experience was going bad. I gain ahead over there also. Reason being that I am training the model ahead of time, right? So all these things are making this approach little more effective as compared to the classical programming approach. But if this is all good, I should have written a death warrant for the death note for the classical programming approach. So is it the truth? No, actually. So whenever I take sessions on machine learning, I keep on telling people, I'm sorry for the whistling on the background, guys. Just make sure that you ignore it because this makes you aware of what's happening outside, for me at least. Anyways, coming back to the session. So the problem is sometimes you would just require a simple approach. Not all applications, not all problems require machine learning. There are a few applications which can be solved by using classical programming approach very effectively. So as just a recommendation, do not jump on machine learning immediately as soon as you see a problem to be solved. Try to analyze whether you need a machine learning approach or the classical programming approach. Okay, just a suggestion, guys. Now, having talked about how you would do machine learning approach will be solving our problems which were there in the classical programming approach, we should be understanding how does machine learning actually does it. So the very basic concept which works with machine learning is the concept of a model and an algorithm. Usually people, sometimes, not usually, but sometimes people get confused between what is a model and what is an algorithm. So from my side, what I can explain you is an algorithm is a set of mathematical patterns and mathematical rules and equations which are to be trained on the data that you provide. So you as a programmer or an engineer or as a scientist, you will be providing the data to the customer, all right, to the model not the customer data to the algorithm, and the algorithm will be training on that data. Once that is done, you are ready with your model. This model is a trained artifact. You could just, it's like a pick and drop thing. You could pick the model, put it in one algorithm, put it in one process, pick the model, put it in another process, however you like. Okay, so what algorithm is basically doing is, let me just highlight this, it will be identifying patterns in your data, and as I said before, you do not need to manually set the rules. So we are gaining on it. Okay, once this difference is clear for you, how will this difference help you? Let me just explain that. Now, whenever you go ahead in your machine learning journeys, you know whether you have to improve on your algorithm or your model. If you are trying to improve the performance of your already existing model, then you have to work on an algorithm. If you're trying to get in a new model itself, you can work on which type of model are you going to get. Okay, so both of these will always go hand in hand. All right. Now, what type of algorithm? See, algorithm is the basis. Wherever you will go, the algorithm is the base for the machine learning. On the basis of algorithm, it's like, what can we say, the bedrock. The bedrock for any machine learning model or any machine learning pipeline is the algorithm itself. So on the basis of algorithm, the model is built. On the basis of the model, the whole machine learning pipeline is built somewhere. So how does an algorithm work? How we make sure that the algorithm is working in a nice way? How do we do that? I'm sure you must have heard of various algorithms, various processes and everything, but how do they actually work? How do you actually work on the algorithm side of it? Now, before I go there, I can see lots of questions coming up. So people are saying that you can't hear me. I'm sure Dr. Anil is very beautifully answering all the questions. Okay, so why does AI and ML always go hand in hand? Venkat, that's a very nice question. So if I could say this, we'll be discussing this in a while as well. It's also a subsetting. So AI, ML is a subset of AI, and when we'll discuss the DL, you will see DL is a subset of ML. So on the whole, it's actually AI, and inside that we have a subset called ML, and inside that we have a subset called DL, right? I hope that's answered your question. So coming back to the algorithms now, guys, what we were talking about algorithms was this. Now, I really want you to absorb this very, very nicely. The reason being, most of the times we understand it on the rough basis, on the touch level basis, and we just jump on to the algorithms, what are the different type of algorithms, and we sometimes fail to understand the dynamics behind it. So it's very important how algorithms make that choice of learning from the patterns. How do they do this? Okay, let me try to explain this with the help of example, how we were discussing the recommendation engine problem. Okay, so any algorithm you will see will consist of two major things. Okay, one is the feature and one is the weight. Over here, the feature is this and the weight is this. In your literature, in your articles, I'm sure you must be reading hundreds of articles daily. I mean, not daily, but on general purposes, you must have seen 100 of articles. So you might see the feature being represented by some other terms also. Do not get confused. It's the same thing. It might be called as input. It can be called as features, or sometimes we also call it as parameters, whatever it is. It's what is the input getting into the system. All right, that is what the features are called. Now, what is the weight? We will be discussing this in a while, but let's understand first what is a feature. It's actually a data point. Okay, in case of recommending a product for the customer, let's say the feature is this product a hat or not? It can be yes or no. Now, features can always have different types of values. Okay, it can be a binary value, which will be 1 or 0. It can be yes or no. This is a type of binary. Okay, or you could have different multi-classes. For example, let's say A plus. These can be different grades, or this can be anything, and A minus. If you're defining the color for a hat, let's say what color is this hat? I could have different categories. I could have green, blue, purple, and so on. Rest, I could also have values. Okay, what is the height of this hat? Let's say, what is the height of a person? All these features are numerical now. So features can have different type of values. Remember this first. Second, one feature should have constant type of values. If one feature is binary, all the values in that feature should be binary. If one feature is categorical, all the features, all the values in that particular feature in one feature should all be same. Remember this. Okay, now going ahead, we were talking about, is this product a hat or no? If it is a yes, we will say it's a 1. If it is a no, we'll say a 0. But let's see, if I have 10 such features, how much importance do I really want to give this feature? how much weight do I really want to give this feature? How do I decide that weight? It comes from the data. Okay. How much weight does this feature will get to define the accuracy of the prediction? Now, I already have my data with me, right? You already know that we have the data from which we are deriving these rules. The model is deriving these rules. The algorithm is defining. If I know from the data that the customer had already purchased 8 hats in the past, I definitely want to give it more weightage, don't I? And if I knew the customer were not purchasing the 8 hats absolutely, I will not want to give it more weightage. So the weightage is defining how important one particular feature is for your prediction. Okay, I'll give you another example for this. Okay, let's say you are defining a system to predict whether a person should be given the loan or not. This is your final output, whether the person should be given the loan or not. A bank is going to define that, and you're defining a model for this. Now, the features can be various features, but one of the feature is whether this person has good credit history or not, right? Now, let's say any credit history be below 700, I'm considering it as a bad, and any credit history above 700, I'm considering this as a good one for my particular system. All right. So this particular feature of having a good credit history for defining a loan is definitely very, very important for me, right? Alongside, I also have another feature which defines where this person is living. Is he living in Delhi, or is he living in Mumbai, right? Now, this particular feature might be important considering various other reasons, but compared to the first feature, which was defining the credit score, the location feature will get lesser weightage, right? So this is how I define which feature should get more weightage and which feature should get lesser weightage. This is how we define the weight of a particular feature. Okay. Now, let's understand the same example of the recommendation system with one more feature. Okay, let's see. The next feature is this item from a particular brand or not? I'm sure you all have your own favorite brands, right? When we talk about favorite brands, people are usually particular with brands. You might like one particular brand, I might like some other particular brand, but we are usually going to buy the similar products of the same brand, right? So is this particular item from the brand Y or not? And from the data I saw that out of the 8 hats that the person bought, only 2 were from the particular brand called Y. So I definitely do not want to give it more weightage. I definitely want to give it lesser weightage. So that's why I'm giving a lesser weightage, which is 0.25. Now, this is how you define the weights and features, and I'm hoping that this concept of defining weights and features is clear. But remember, what we saw right now was just considering for one person. We have to generalize this whole concept of weights and features to the whole data set. We have to adapt this whole concept to the complete data set. Okay, remember that. Once you have your picture ready with the equation, all you have to do is the make prediction. So if f of x is greater than 1, all after calculating all these equations rules, if f(x) is greater than 1, you are going to recommend that product. If f of x is lesser than 1, you're not going to recommend this product. This particular rule or this particular thing might change with time, might change according to your requirements, but this is in general how it works. I hope the working of an algorithm is clear to you guys by now, so that we can move ahead. So I have a question from Harsha, that who defines the weight, the model or the trainer? The model, Harsha. This is the responsibility of the model to define the weights on the features. Okay. And this is how it is different from classical programming approach. In classical programming approach, I would have had to do that. In models, in machine learning models, the algorithm will be doing and adapting to the data patterns and giving it features and weights. Okay. I hope it answers your question. Now, what kind of algorithms are used generally, right? Let's discuss that. Usually, we generate or we classify our algorithms in 3 categories. One is supervised and then there is unsupervised, and then we have reinforcement learning. Okay, we will be discussing these particular algorithms one by one. All right, first let's discuss the supervised algorithm. Now this is one of the best examples of supervised algorithms where you are trying to identify a picture, and you're trying to just put a black box on the car. So you're trying to identify a car from a picture. So remember, for a supervised learning, you have to make sure that you give the input as well as the output. Okay, so for example, if you are giving the inputs as the pictures, you also have to mark the box for training. Okay, this is what you have to do if you are going to use a supervised learning algorithm. Another example I could give you is if you're trying to predict house prices. This is one of the very it's famous and common projects people do in machine learning. It's available on Kaggle. Now, if you are going to predict house prices for one particular area, and you're going to use supervised learning, what you will have to do is, along with the features, you will also have to provide house prices for the data, for the training data, right? If you do not have the house prices, or if you do not have the target, if you do not have the output, you cannot teach a supervised learning. Supervised learning always teaches this way. You have the input, you have the output, you tell the model, this is the input, this is the output, try to make relationships out of it, and try to learn the dynamics inside the process. Okay, this is how supervised learning works. So once the model learns the dynamics of the process, how the process is originating and everything, whenever you will be providing the new data, the job of the model will be to put the output on the new data. In this case, that was the bounding box. The model will be trying to put the bounding box on the new data, which is the inference for us. Okay, this is how supervised learning works. Now, there are different categories of supervised learning, right? One is binary classification, one is multi-class classification, and one is regression. Okay, let me try to explain this example along just the way we were discussing the house prices examples. Okay, the problem formulation can require different types. If I was saying that my house prices are going, let's say, if I'm saying my house prices are going either up or down, right? So these are just two categories. Okay, either the prices are high or low, are they going up or down? This is a binary classification. Okay, but if I was saying that my house prices are low, high, higher, or very high, okay, if I was to predict these from my output, this will be my multi-class classification. Okay, because I have different categories in this, more than two categories. Now, if I have regression, what this example will say, what is the exact house price, right? Now, this has to be a numerical value, a continuous numerical value. It can be 75K, right? It can be 75 point, I'm sorry for this, I'm really bad at writing it like this, 71 5.1, it can be 80, it can be anything, right? Any value that you can think of, right? So this is what the regression will be. So depending on the target output, your type of classification or regression will change in case of a supervised learning. I'm going to park a question here. Will there be a similar classification, similar categorization in unsupervised learning? We will be discussing unsupervised learning in a while, but I want to park this question for you guys. Will there be a similar categorization for unsupervised learning? Just remember this question. I would want you to answer this in a while. Okay, now coming to supervised learning, as I was explaining, binary is whether the transaction is fraud or not. Multi-class is whether this particular transaction should go to IT support, to returns, or to accounting. And regression is, let's say we're just predicting a particular value. So these are all examples of supervised learning. I hope supervised learning is clear to you all, right? Next is unsupervised learning. Now let's discuss what happens in unsupervised learning, guys. Okay, so when we're talking about unsupervised learning, what we're really saying is we want something which can cluster our data, without the target. In many cases, you will have data on which you do not have any target, right? For example, you might have launched a product in the market, and you want to understand how that market, how that product is reacting, what is its reaction in the market with a new product launch, what is its reaction from the audience, from the customers. So you do not have data. How do you respond to it? What you could do is, on the basis of the sales, or on the basis of other features, you could divide it into two groups. These are the people who are actually liking the product, these are the people who are not liking the product, right? Until and unless you have a specific output, you cannot do supervised learning. So what do you have in that case? Unsupervised learning. Unsupervised learning comes into picture when you do not have a specific output or a target on your data. So this comes to rescue. How does this work? How does unsupervised learning works? Let's try to understand this. On your screen, on the left side, you see a cluster of data, lots and lots of data points. What supervised clustering, supervised algorithm will be doing, or supervised learning will be doing, is dividing these data into different clusters. One definite question is, how could you do that? How would you do that until and unless you have an output, right? So how it does it is, it tries to calculate the distance between the data points. If the distance between the data points are close, is small, it puts all the data points which are similar to each other in one group, and it also puts all the data points which are dissimilar to each other into different groups. You have to remember this. Most of the times people just think about putting similar data points into one group. Not only that, you also have to think about putting all the dissimilar data points into different groups, okay? So this is one thing which you always have to remember. Now I'm getting some questions here. How do we know what we need to use what at a time? So Ramya, that's a very nice question. Depending on the problem formulation, as I said, you could formulate one problem into different ways. For example, a very simple example, the simplest example I could give you is, let's say you are evaluating one particular student, okay? And I could evaluate him saying, yeah, fail or a pass. I could evaluate him saying, these are the grades I'm going to give him. I could evaluate him by giving marks, okay? So these are the three different ways of evaluating a person. So these, depending on the problem formulation, okay, that will define what type of algorithm you're going to use. I hope that answers your question. And for unsupervised and supervised, you always have to think about whether you have the target or not. If you have the target, supervised. If you do not have the target, unsupervised. How does multi-class and regression differ? Okay, that's a very nice question, Shrisha, again, because there is one gray line between multi-class and regression. In regression, we always say when you're predicting one value, okay, that has to be continuous value, right? Numerical continuous value. In multi-class also, there can be sometimes numerical values like 1, 2, 3, 4, but there have to be categories. When we work on Python, or when we work on, for that matter, any programming language, the data type that is coming in has to be either categorical or numerical. So if the data type is categorical, that is going to be multi-class. If it is numerical, then it's going to be regression. But yes, as I said, sometimes if there are more than 10 classes, it never, we have a gray line on deciding whether should we put it into multi-class or whether should we put into regression, okay? There is generally a gray line, and we have to take a decision on ourselves at that time. Nice question, guys. Very nice question. Now, another one is how we are going to decide who are similar data point and who are not similar data points. That's exactly what I explained, Manisha. We calculate the distance between the data points. So usually that is done on the basis of the algorithm. What type of algorithm are you going to use? A general example is, first of all, you put a centroid, okay? And from that centroid, you calculate the distance of all the points. Whichever are closer to that centroid, you put into one group, and whichever are not closer to that centroid, you put into another group. So that so distance is the way we calculate it, okay? Yes, sometimes, Rahul, most of the times so this comes with experience also. It's somebody said that there is no compression algorithm for experience, right? So most of the times this comes with experience, what kind of algorithm will be suitable for one type of application. But general basics also sometimes, most of the time, general basics of understanding the mechanism behind the algorithm makes clarity that what type of algorithm you might be using. Having said that, most of the times you will be trying at least a couple of algorithms for your problem. Who decides what is the criteria for similar or dissimilar? So the criteria has to be decided by the algorithm, what algorithm you're using. So that will be coded right there, if I could say that. So if you're going to use distance, if you are going to use the similarity or dissimilarity, whatever, similarity in itself has different paradigms. So you can use whichever measure you would like depending on the algorithm. It all comes in. Even if for distance, there are different type of distance. You have Euclidean distance, you have Hamming distance, you have different other types of distances. So totally depends on the algorithm. We have beautiful questions, guys. Thank you so much for asking all these questions. That means you are actually listening to me, and that gives more pleasure to me. I'll just take couple of more questions, and we shall move forward. Conducted a town hall, we took employee with experience as a sentimental analysis on survey or supervised learning. So sentimental analysis, definitely, if you're going to do the text analysis, that's going to be sentimental analysis. If you're just going to measure the responses, let's say 1 to 5, okay, then it can be put into supervised algorithm. And yes, exactly, Rajeshwari. It's actually how the boundary decided. So that's the nice question. Boundary is always a problem with the clustering algorithms. So even in clustering, you have different types of clustering. You have k-means clustering, you have BB scan. So depending on how harsh or how flexible boundaries you need, you will be changing the algorithms. When we train our model on existing data, how do take into account the deviation in the future data of our model? We will be just covering that, Summer. That's a very, very smart question. We'll be covering that, okay? Now, moving ahead. We were talking about unsupervised learning, and the use case is a very simple one in this one. We are trying to detect a speed camera failure, whether a speed camera failure is actually an indication of a failure or is it just an outlier. Okay, so you can see there's lots of data, and we have clustered the data into two portions. Okay, outlier what is an outlier? Outlier is a very simple thing where you just something out of the ranges from the normal data. Okay, so that is what an outlier is. Now, if you see, we can see that some of the data points are actually lying near the clusters, but some of the data points are absolutely away from the cluster. So we can see that these are actually going to be the true positive or the indicators of failures. The rest of them are most probably false positive. So we can actually use this. This is how you use clustering in anomaly detection. Okay. Now, I would like to pose the question which I had asked you guys. Can we use clustering, or can the clustering be defined as different categories of classification and regression? I would love to see your responses. Can we have classification and regression in unsupervised learning? Very quickly, guys. I will repeat the question for the last time. Can we have classification and regression in case of unsupervised learning? I'll give you 10 seconds to answer. No, Sunil says no, no, yes. People say yes and no. Could you please write something in chat, because the chat is activated only when you write something in the chat. I'll do that. Okay, there you go. Okay, there. I hope that is, sorry for the spelling mistake. But you don't need to write anything on the chat. You can use the question window, okay? most of the answers I say is no and yes. The audience is split between yes and no. So see, I will still leave up to you to work up on your minds on this, because see, unsupervised learning, you're not defining any output, okay? And if you remember, the division of supervised learning in between the classification and regression was actually done on the basis of the output, okay? So how are you going to do that? I will leave up to you guys to think about it tonight and just work around your mind on that. There is an answer for this. Most of the times people confuse in literature. There are some literature which will say yes, it is possible. Most of the literatures would say no, but I would like to you guys to decide on your own, is it possible or not, okay? All right. Now, yes, I see there are always good answers and bad answers. There is sometimes which is no wrong and bad, wrong and right, okay? So this is one of those areas where there is no wrong or right, but there are good answers and bad answers, okay? Now, coming to the most interesting type of algorithm, which is reinforcement learning. Now, what exactly is reinforcement learning? Let's discuss that. Reinforcement learning is pretty much how we work in our daily lives, right? So let's say I'm going on a path and I do not know, I'm going towards a destination and I do not know what the path is to be taken, okay? All I can do is I can go on that path and I can learn from my mistakes. So every time I take the right path, I will be rewarded by, taking a leap. But whenever I take a wrong path, I'm definitely penalized by losing my time, right? So this is exactly how reinforcement learning also works, okay? So let's understand this with the help of a deep racer. Deep racer is a very cool thing by AWS. Let me just hold on. I will be posting you a link for this, or maybe I can just actually show you that as well. Give me one moment, guys.
Grisha, one update. Please,
Yes.
put all the links only in the question box, because chat box is disabled for the audience. So questions
Yes.
are coming from the audience that it is read only. So better you put all that links there in the question box only. Thank you.
Yes, yes, thank you, Dr. Anil. So as Dr. Anil said, we are not putting any links on the chat window. That is just for saying hi to everyone. You can only read there, so that's why I just posted hey there. But yes, whatever links we'll be posting, that will be on the questions window, okay? Now, as I said, this is where how the deep racer will look like. It's actually based on the reinforcement learning. This is a very cool competition where you also can participate. Everyone can participate in this competition. How this works is basically it's like I'm sure you must have seen those car racing competitions, right, in the leagues. So you have an environment in which the car will be racing. You will be defining the path of that car. You will be modeling that particular car, okay? What that deep racer or the car has to do is it has to take the path to complete that particular circuit, okay? And it will be penalized every time it take a wrong path. It will be rewarded every time it takes the right path, okay? Now I'm just going to put this link to your questions window, right? So that you can actually, yes, Pratik, yes, because that's how GoToWebinar works, okay? Correct. I'm sure everyone must have got this. This is how the reinforcement learning works, and let's just discuss it further. So if you can see the screen right now, you have an agent, which is going to be a deep racer car in our case. The action will be taken in the environment. On the basis of the action, you will be either rewarded or penalized. I'm sure this is exactly how we human beings also learn in our daily lives, in our social circles. Whenever we take a good thing, we are either rewarded with praises, we are either rewarded with gifts and grades, good marks, prizes, promotions, everything, and whenever we take a bad decision in our lives, we are sometimes penalized by losing maybe something, but it always is an experience. It always is a learning that we are not supposed to take that wrong path. Similarly, the reinforcement learning also works. It learns from its mistake and the right things. Okay. I'm sorry, Bhushan. Let me just check my audio. It's going all fine from my side. It will be great if you can just try to refresh your screen. Um, okay, well, let's have a few more questions here. When we get an output from a supervised learning after frequent training, then they are classified. Yes, maybe. You might be right in that. Convert supervised classification to learning. Yes, that's a nice answer. How practically this can be done from scratch through coding. You do have various reinforcement learning algorithms, and so it is basically state machines that is done using state machines from one state to another state to another state. Yeah. Okay, going ahead. What is deep learning? This is one area where it's thriving, I would say. Everyone is talking about deep learning. What exactly is this deep learning? Okay, let's try to understand that now. So this is the subcategory of machine learning. How it works is when we try to solve problems which are getting complex in nature day by day, we need more sophisticated or more improved algorithm, right? Everyone knows this. But what happens is as we increase the sophistication or complication of the algorithms, we also need highly computational resources. And that was a challenge some time back because back in the day, we did not have access to the computational resources as we have today. It was not so agile, I would say. To get a compute, to get a good GPU or to get a good CPU for that matter, we had to wait. We have either have to go to market and just get it done or so on. In today's time, it's just a matter of a few clicks and then you get your server or EC2 instance or a GPU instance for yourself. I mean, it's as simple as possible. So these are the reasons where, you know, you could talk about getting the resources right to be able to do all the functioning that is required for deep learning. But how could you relate with deep learning? Let's try to understand this. Okay, I would like you for a moment to go through this slide. Okay, in the meanwhile, let me just go through the questions one more. So I'm sure you must have gone through this. So what's happening is AI, when we say that we are defining a machine which can play chess based on some rules. Now, these rules can be defined by a system. These rules can be defined by myself, but basically an intelligent machine. We are defining an intelligent machine. Okay. Now, if I am doing this from the scratch and making the machine learn to play chess on the basis of the past data, I'm not telling the machine to define these rules. The machine itself is trying to learn from the past data. That is machine learning. Okay, but if the machine can learn to play against themselves, that is deep learning. I'm sure you must have heard of various examples, various systems these days which are coming ahead saying that machine learning is beating the chess champions every time. So this is where we are leading towards in deep learning, guys. Okay. Now, how is this implemented? How does the deep learning work? Deep learning works on something called artificial neural networks. How artificial neural networks work basically are how our brains work. When I was first introduced to neural networks, it was in 2005 or 6. And I was totally taken aback by this concept, which said that we are trying to recreate how your brain works. I was totally taken aback by that. But this is actually how it works. So in your brain, you have some neurons, and whenever a neuron is activated, it gives you the response, right? Similarly, in a artificial neural network also, all these are your neurons. This is a neuron, this is a neuron, this is a neuron. All these are neurons. And these neurons are connected by several connections in between each other. And they will be activated by input. So this particular neuron is activated by these two inputs, and similarly this particular neuron is activated by these two inputs, right? So every time an activation is done, the neuron will be giving you an output. So these are all the outputs, right? And finally, when we collect all these neurons, I will be getting an output from the artificial neural network. But how is this particular thing called deep learning different from machine learning? And this is one of the questions that somebody had asked me, how Abhishek has asked me, how ML really different or related to neural network. So again, as I said, neural network could also be used in machine learning and can also be used in deep learning. I'll explain it how, but yes, yeah, I will be just taking up that question. And Kartike says, does that deep learning is unsupervised learning? Not exactly, Kartike. In fact, there are very rare examples of deep learning and supervised learning combining that. There are very few examples, but mostly the applications or the uses of deep learning you will see are supervised learning, where you give the output. Okay, but yes, there are examples of unsupervised deep learning as well, but a few as compared to supervised deep learning. Now, where is the question? Okay, where's the question window? I'm answering the questions on the basis of whatever I'm getting. Okay, will we be touching AWS cloud also in this? We will be trying to mention it, but not details. Okay, all right, let's get ahead. How deep learning is different from machine learning and from the classical programming approach. Let's try to understand that, guys. Okay, so when we were talking about classical programming approach, we were saying that we will have to create the programs, the rules. When we were talking about machine learning approach, we were saying that we will have to define the features, but the model will be defining the rules or the weights. We were saying, comes deep learning, what the deep learning will be doing, it will be doing now more so ever. So it will be defining the rules, it will be defining the features also from the data. Okay, so this is how machine learning is different from the deep learning. All right, there you go. So this is how deep learning and machine learning and classical programming is different from your all different approaches. I hope this makes sense to you now. Okay, now moving ahead, let's try how you can do image classification using an artificial neural network. Yes, was just in a while. What is the player's moves are substandard and it fed into the system? Would not AI chess system be crappy as well? I would not call it crappy, but it will be lesser advanced as compared to the machine learning one. It is not crappy yet. Okay. Yes, they are changing. What is the current screen showing you? I can only see the example screen. Can you please explain the reinforcement learning field? I'm sorry, if the time permits, I'll definitely want to do that. Explain the reinforcement learning if the time permits. Okay. All right. Now, moving ahead, this is how image classification could be done using artificial neural networks. Okay, when we talk about image classification, what we're trying to do in this particular problem is we are trying to identify what is there in the image, in the particular picture that we are talking into concern about. All right. Now, like you can see, the first input or the pixels are just a very bare pixels. Okay, whatever pixels are there, they have been extracted. In the next layer, if you can see, more detailing has been done, more detailed information is being extracted. It's pretty much like understanding it from the example of how sieves are arranged, right? From the one sieve you get the finer grains, and then you use another sieve and then you get finer grains, and then you use another sieve and you keep on refining and more the grain quality. Okay, and if you remember, I'm sure you must have gone to the tea gardens, right? In the tea gardens, they explain you how tea is refined into several processes, and each tea is different in the terms of the type of the size of filtering, right? So this is exactly what works in the image classification also using an artificial neural network. Every layer, once it goes through every layer, more refining is done to get a better features out of it. Okay, so if you can see, firstly we were just getting very coarse images, which was edges. Then we started getting corners and contours, and then we started getting better details out of it. But does it I mean, can you connect it with the basic concept of the algorithm that we were talking about in the first phase? Is this similar to what we were talking about when we were saying that we have features and we have we have features and we definitely have weights and everything? Can we relate to it? Yes, we can relate to that. How? Let's try to understand that, guys. So if you can see right here, these are going to be the features now, people. These are all going to be the features, and I will be applying weight on these. Now, since I'm saying I'm using a machine learning or a deep learning, it will be doing it automatically. I will not have to do it. It will be doing automatically. The weights, updation, everything will be done automatically inside the network itself. So this is how image classification could be done using ANN. And now we move ahead, the example of how impactful the deep learning is. Okay, before again I move forward, I will like to see a few questions. What is ANN? ANN is artificial neural network fluid. And then we have more questions. Can DL do predictions without any training sample data? Can it predict the future outcome? It can predict the future outcome once it is trained, but you do require training samples. Okay, to make predictions you have to train it. But there is something called transfer learning as well, in which what you do is you take up a pre-trained model and you custom it according to your requirements. So yeah, that could work also. That is called that. Go for transfer learning if you want something in which you do not have enough training samples, or you do not want to invest into high computational resources. Sonam, I'm really sorry, but I mean, if everyone else is also having this problem, they would let me know. I'm sure, Dr. Anil, can you confirm me if the voice is echoing or is it fine?
It's completely fine, Girisha. I've already informed them, so you may continue because there is an internet issue also at their end also. Yeah, thank you.
Thank you, Dr. Yes. Sonam, I would request you to keep checking on your system. Now, can you explain deep learning diagram once again, the previous slide? I'll definitely go there. Hold on. Who defines, let me just see another question. Who defines the neurons in an artificial neural net? That you have to define. How many number of neurons? Definition of a neuron is basically the same. It is a combination of input and outputs. And what function you will be using, what activation function, is it a sigmoid or is it a linear, that you will be defining, and what type of architecture are you going to do. So how many neurons, how many layers, that also you will have to define. Okay, now, okay, so is there a standard or an algorithm that defines what neurons are? Neurons are basically just the mathematical model, right? So you have the input and the output, and the output is dependent on a linear combination or a non-linear combination of the inputs along with the weights. So this is what a neuron is in simplistic way. So I guess we have answered most of the questions, and most of the people are asking to go back to this previous slide. I really want to go back to there, but let me just cover this thing up and then we'll go back to the previous slides once more. Okay, so as I was saying, guys, what you're actually trying to do when we're talking about impact of deep learning here is how deep learning has changed the complete scenario of making predictions. Okay, let's try to understand that with the help of very simple example, which is called ImageNet visual recognition. We will be touching upon cloud learning also in a while, but hang on, we will be touching on going there, how you could use cloud for machine learning, but we'll just take a few moments for that. I'll be showing you how you could work on SageMaker and just very quickly how SageMaker will look like. But before we go there, just let's try to understand all the basics. Okay. Now, coming back to the impact of deep learning. So there's a competition called ImageNet competition, which defines you have to classify the images in the competition. It is a large data set. By 2010, when the competition was actually launched, and 2011, the accuracy was 74.23. And in 2012, it jumped tenfolds by 81.8%. What happened? What really happened at that point of time was it was the first time CNNs, convolutional neural networks, were introduced, right? So yes, thanks for the information, Kashif. So ImageNet was created by Dr. Feifei from Standard University. That's absolutely right. So this is a competition which is open for everyone, basically. So you could use that competition, all right? So can you see how good we were doing when the CNNs were came? And by the end of 2016, we were actually crossing the human accuracy also. So it says that the human accuracy is somewhere 94.9%, and we were even crossing that. Just take a moment to absorb that, guys. We are trying to create systems as humans. We are trying to create systems which are surpassing our own performances. Isn't this magical? You know, this is absolutely great. Now, as I said, how do you combine all these things into one picture? How do you do this? So this is done usually using a machine learning pipeline. So what happens in the machine learning pipeline basically is you first of all formulate the problem on the basis of your business problem. So this is where comes the question somebody asked, how to decide what algorithm you're going to use. This is where the basic definition of algorithm will be derived from, because once the problem is formulated according to the business needs, you will be defining what kind of algorithms, what kind of problem you're going to solve. Then you will be collecting your data, you will be pre-processing it, and then you will be visualizing it. As you know, a very famous saying, a picture is 1,000 words. You can visualize this to understand the dynamics, and then you will be training and tuning it, and finally you will be evaluating it. Now somebody asked me, do we have to retrain our model? Absolutely yes. Most of the times what happens is, especially in these times, the data is changing so rapidly. So there is there's a drift in the data. So for example, if there was a fashion website and the recommendations were coming from the recent fashion trends, that will not work for more than 1 or 2 years, right? So you will have to retrain your data on the latest trends. So then only it will be giving you better recommendations. Similarly, for the finance market, for the financial data, you have to make sure that your data is retrained on the new data very, very frequently. So yes, the answer is yes. You have to make sure your data or the model has been pre-trained on the new patterns. Okay. Now, if your system or if your model meets your business requirement, you are good to go for deployment. What if it doesn't? You go back for feature engineering, or you go back to augment your data to make measures and see if you can improve the model to perform as per your business needs. Okay, this is the machine learning pipeline. If you have understood all these things, what is validation? Okay, let me just go back to a few more questions here. What is validation data set? So validation data set is pretty much like saying, if I have to, so remember how in your schools, we used to have those tests before my mother used to do this, okay? So my mom used to create tests for me before I had a very important exam, right? What she used to design those tests was for whether I was doing good or not, and whether I need to be learning more or learning, better in some area. So this was kind of a validation for me whether I'm ready for the next test or not. And that final test would define whether I was ready to go to the industry or not. This is how it works even for the machine learning pipeline. Once you are training your model, you have to check it, right? But usually we check it on the test data whether it's doing good or not. But to make changes, we need to make sure we have a sample data to validate it, right? Once it sees the test data, it will start performing well on this, even if you retrain that. So always remember, the test data should be unseen to the model for a perfect evaluation. For a fair evaluation, always make sure it's pretty much like, say, if I were appearing for a test, if I knew the questions, I'm definitely going to learn them and go back to the question back and perform well, right? This is pretty much like saying that. But If I did not know about the question in the test exam, I will be evaluated fairly. It's pretty much like saying that. So always remember, your test data should never be seen to the model. Okay, and that's why you have validation data set to tune your model. For model deployment, it doesn't really matter. It's always a case of what type of servers you're using for training most of the times, because that is where the model is being trained. For deployment, most of the techniques, most of the platforms remain same. It also depends what kind of input are you getting for the deployment. Is it very sub-second latency, or is it coming in batches? So that will define the changes, but not MLNDL. Deployment technology or techniques will remain pretty much same for both of them. It's in the case of training where the scenario changes. It depends on the data. So if it is a very frequently changing data, then definitely. So when there is something called concept drift in SageMaker, which is AWS SageMaker. So you have something concept of concept drift, which you can use to find out whether you should be training your data frequently or not. So it tells you, it diagnoses that. So there is the concept of convolutional neural network and artificial neural network. So in a convolutional neural network, it's a much deeper network as compared to the artificial neural network. Also, there are slices. So look at the convolutional neural network like making slices of an image and going deeper and deeper and deeper. In artificial neural network, it is refined, but not at that level. In convolutional neural network, the details are much more refined at each layer, if I could put it in the simplest way for you. Then we have, how is production live model feature engineering happens? That's a very interesting question, Rakesh. So how does it actually happens is, while the model is already in testing, we have A and B testing. Okay. So what we usually do, we give most 70 or 80% of the traffic to the A model, and we keep making some changes in the B model and just give 20 or 30% of the traffic to the B model. And that is how we can make live feature engineering happen and evaluate it as well. I hope this answers your question. Yes, neural network is pretty much like a black box, Kashif. So Kashif's question is, how do we debug neural networks, because we don't know what's going on internally? Neural networks is pretty much like a black box until later, where we actually see inside the neurons, and we can actually not see what is going inside the neurons, but we can actually now, with the help of few technologies, we can actually see what is happening at each layer. We can extract the output of each layer. So that is possible now, and we can actually work out. Okay. Sudarshan, my LinkedIn profile is Dr. Girisha, and I will be sharing that later on. We are planning on creating a model healthcare on essential. I'm sorry, we will not be able to take on personal questions, but I will definitely advise you to go to AWS blogs on machine learning. So that over there you will find these. There are several examples on healthcare and how to use machine learning on healthcare using AWS Human. You can go for AWS blogs. Can you take a basic problem statement and tell us step by step the decisions you will take? Yes, definitely. That is what we are going to do right now after this. So DL will help, so validation will help everyone. Training helps through backpropagation. Backpropagation is pretty much for updating the weights, that is for training, you're right. But validation is where you are done with your training, you're ready with your model, and you want to know how you can improve on that. So that will be applicable even for deep learning or for machine learning. Okay, so I guess we're done with these questions. Right, Rakesh. If it is going to be very rigorous changes, you definitely want to have the model ready on the back end and keep on working on it until you put it into production. But if it is very small change, it can work. And these days there are automated models which can do the feature processing for you as well. For example, deep learning, you do not need to do the feature processing much. It does it on your own. Okay. So I guess we're done with the questions. I will go back to the whole pipeline with the help of a call center problem statement. This is a case study. This is a real case study which was done at Amazon. So at Amazon, we were having problems because when the customer used to call a call center, most of the times, I think it happens with every call center for that matter. Most of the times, I'm sure you must have been directed to the wrong department, and even if it was the right department, he or she would say, "Let me transfer your call to my manager," and it's so and so. So that always led to a bad customer experience. And at Amazon, we cannot actually accept that because customer obsession is our first priority. So what we really want to do was, our problem statement or business problem was, we wanted to route the customer to the correct agent at one go. Okay, this is what we really wanted to achieve. Now, how could we convert this into ML problem? We could get the information on our customer and on our clients, and we could use that customer route we could use that information to route the customer to the right agent. This is what we're going to do. How are we going to do this? We will be collecting the data. We already have the historical call records. We already have the skill sets of our agents. We could combine that, integrate it in one place. But what are the features going to be from that data? How are we going to define those features from the data? Let's understand this. Okay. So one can be, when was or what was the customer's recent order? Because if I have purchased some item as a customer from Amazon website, there are chances that I will be calling the customer care regarding that particular order. Does the customer own a Kindle or not? If I have a Kindle, there are chances I might be calling the customer care for the problems in my Kindle, or how could I register my Kindle, or so on. Am I a Prime member or not? If I'm a Prime member, there are very high chances that I'm going to call my customer care for renewal or for problems or for changes in my Prime membership. So these are the features I could derive from the historical call records and the users data. Now, there are various ways I could simplify my data. Okay. Now, if you can see on the screen right now, you have different categories in which the agent skills could be divided. You have Kindle troubleshooting, Kindle payment, Kindle refunds, Kindle ordering. But for this particular problem, we don't need so many of bifurcations. Okay, what we could do is club these all together into Kindle skills. That will do the purpose for me. So this is the type of pre-processing which you could do on your data for exploring, right? Another one is this. So using visualization, you can see that you are going to find out what is the maximum number of calls. You can see maximum number of calls for the call center were actually related to the returns. Next came Prime membership, next came Kindle, and next came miscellaneous. You could use this data to maneuver your model, or to make sure the model learns from it. Okay, so you could use all these information. But in these two processes, I was not rendering my features. I was not changing anything, right? In pre-processing and visualization, I was not changing anything. What happens in feature engineering is I'm engineering the existing features. How do you do that? So very quickly, I'm going to point these out as number 1. I'm going to put that as 1, 2, and 3. Very quickly from you guys, I want to hear, which one of these do you think is the most difficult feature to understand? Most difficult feature to understand, to make sense out of it. Okay, very quickly on the question screens, guys. Which one of these do you think is the most difficult one? 1, 2, or 3? Owns Kindle. Okay. 2, 3, 2. Most of the people are saying 2. 1 also, yes. Very nice. Time, yes, absolutely. Recent order, right. 1, 2, qualitative data, right. That's sometimes right. Absolutely. See, so even here I can see the majority of the people are saying 2. Majority of the people are actually saying 2. Why are we seeing this? Because this not make any sense. I'm just seeing a date and a time on it, right? It won't make much sense. Definitely owning a Kindle, yes or no, I could change into 1 or 0 to make more sense. Yes, I could change it. recent order had, I could change it to categorical. I could do that. But the most problematic area I see is here, the date and the time. So I want to change it. I could delete it. This is what I could do. Or I could change it to this way. Do you think it looks better now? Do you think it looks better now? The feature, it would make more sense for my process? Yes or no, guys? Absolutely, yes. Absolutely. Absolutely. What about time? Yes. See, the time is might be a more important feature, but right now, if I am putting in this 70 days, it might make more sense, and I can make it continuous also to capture the time as well. Okay. Yes, absolutely. Thank you so much for responding, guys. I really appreciate it. Thank you so much. Okay, so this is how you could do feature engineering. Now, the next thing is the model training, and this is where I was trying to explain the training validation and the test data set. So you will be having 80% of your data as the training data, and you could use 10% for the validation for making sure that your model is performing fine, whether you want to tune it or tweak it or something like that. And finally, for evaluation, you can keep the rest of the data, which is going to be 10%. Okay, so this is how you could work on your training of your model and dividing your data. But one thing is left: how do you tune it? What is model tuning? Model tuning is pretty much like changing gears in your car. So for a better efficiency or for a better mileage, you change your gears, right? And similarly, to reach somewhere very very quickly, you change gears. You tweak it, right? Similarly, you tweak the gas, hitting the gas. You also tweak that. Okay. So this is how you tweak your model also to perform better, to perform better and to improve its performance. You tweak the parameters of the model, and this is called as model tuning, right? And finally, uh, the time is the finally we will be evaluating our model by these parameters. How often did it route the calls? How many times on average the calls have to be routed? And do these results meet our business needs or not? And finally, we can have our customer being routed to the correct agent. And this is how a machine learning pipeline can be used in a very very real problem statement, which in which we require the customer to be routed to the right agent. This is the most simplistic one, and this entails every stage of the pipeline, machine learning pipeline, that you can think of, guys. Okay, so with this I will take up a few more questions, and I'll just very quickly show you the SageMaker console. No, not why would this lead to overfitting, unless and until the algorithm is overfitting. So I do not understand why would it lead to overfitting on mine. The problem with overfitting is usually with the algorithm. When the algorithm is you have to regularize the algorithm to make sure it doesn't overfit. Okay, most of the times. Yes, absolutely. Everything is perspective. Absolutely, Hemant. I totally agree with you. Most of the times we ignore things, but yes, every person, as every, it's like an art. Machine learning, especially feature engineering for that matter, is like an art. Everyone has their own vision. Everyone has their own way to do things. For example, somebody like me, I prefer to keep categorical features and try to make relationships out of that. There are people who I know who do not want to keep categorical features. They just want to remove them and convert them into numerical. So everyone to its own, yeah. Everyone has their own preferences. Hyperparameters are basically, if I have to tell you, for example, a neural network, hyperparameter could be what kind of learning are you doing? Okay, are you going to make the model learn very fast? Are you going to learn the model very slow? Just the way in a car while you're driving, what type of gear are you putting? How much you are hitting the gas? These are your hyperparameters to tune your performance, to tune your car's performance. Okay. For every algorithm, these hyperparameters will be different. Very slight, very slight. So you have to make sure that your process has been random by in selecting the training and the test features. If you make sure that, there's a very low chance of data leakage. Model evaluation is where, see, there are various ways where you can evaluate the model, but that will totally come from the business problem. I might want a better accuracy. I might want a better precision. I might want a true positive. I might want a proof, I mean, false positive, whatever. So it is totally and completely defined by your business problem. Okay. What is regularization? Regularization is where you are putting limits on your model to it has overtrained. So that is where overfitting comes into the picture. It's like saying you are getting the noise also. You're learning on the noise also. So you need to stop at that pace. So that is called regular. You're regularizing the model training. How to identify the right data set and optimal data set that would be required to train the model initially. Um, so you do not have to decide it. Once you do the feature engineering, that will come to the picture itself. Okay, that should not be a big problem once you do the right feature engineering. Okay. All right. Getting confused with algo and model. Could you explain again with some examples? Where did this fit in the case study? Right. So we did not talk much on the model though, but I could explain you once. So over here, if you could see when we were doing, okay, let me just show you. When I was doing this, I was actually defining working on the algorithm. I was training the algorithm. I was evaluating the algorithm, and once I was done with it, I would be testing it. So my model is ready. Okay. So this is how the difference between algo and model is. Ahmed, I'm really trying to read all the questions. I'm sorry if I missed yours. I'm really trying it to read all the questions. Okay. Um, okay. How to identify the right data sets and optimal data sets? Okay. So as I said, the differentiation is very nice once you get the feature processing done right way. When we go for feature selection is basically comes into feature engineering. What features do you want to keep and what features do not want to keep? So that is where the feature selection is going to fit in. Okay. All right, guys. So this is for the question part. And what exactly? So this is the last question I'm taking. What exactly matters, data quality or data quantity in setting one? That's a very, very good question. Definitely, both of these. You cannot. It's like a trade-off. You cannot you cannot expect a model to train on bad data, even if the data is large, and even if the data is very high quality and you just have a few samples, then also the model would not work. So you have to have a good trade-off on that. Thank you for that, Ahmed. Thank you. I really appreciate your input for that. What is the basic difference between supervised and reinforcement learning? Supervised learning is where you do not get penalized or do not get rewarded. You know how to do the training. But in reinforcement learning, that is not how it works. You have to create your own path, okay? And you are penalized and rewarded according to you. So I would very quickly want to go through the SageMaker also, just to give you a glimpse of how the SageMaker would look like, guys. So just give me one moment so that I can actually show you that. So in the meanwhile, okay, there's one more thing I really want to show you. Just give me one moment. So you have something called SageMaker free trial, wherein you can actually work on your own using the SageMaker free trial. Okay. So using SageMaker, you could do all these things. You could label your data, you could build, you could train and tune, and finally you can deploy also, right? So most of the things that you do on Python can be done all here, but you're also leveraging the capability and the breadth and the scopes of deploying using automated servers, and you don't have to worry much about deploying. The AWS most of the times take care of itself, and SageMaker is a fully managed service, which means that you do not have to worry about patching, you do not have to worry about orchestration. SageMaker will be doing that for you. You just have to build your own model and train it. That's all you have to do. We do have various things also. So if you ever want to learn more, so this is what you could do. You could learn at your own pace, or you could learn from the AWS experts, and you could come. There are various courses. One of the courses is machine learning pipeline on AWS. There are other different courses also. I really encourage the idea of getting ML certificated also, because that helps in creating the awareness about you being knowledgeable about ML on the cloud. So this is a very nice certification on ML using the specialty exams with AWS. That's a very great certification, guys. And wherever you want to have more help, you always have this digital library where you can learn on your own pace. Okay, so I guess this is it from my side. I guess, yeah. So yes, there will be a few more things you would like to understand. There would be a lot more things you would have to go on for your machine learning journey. But I can just wish you very good luck for that. Feature engineering slide. Okay, Sandeep, I'll just explain it to you. It's pretty much like how you would like to delete some features, keep some features, or change some features. Okay. So for example, if you're getting a date timestamp, that date timestamp won't make much sense to you. You might want to convert into number of days. Similarly, if you are getting, let's say, the pixel value might not make much sense to you, right? You might want to convert it into whether it's a gray pixel or a white pixel or a colorful pixel. So whatever you want to change it into. So this is how feature engineering works. What are the cost of these courses and certifications? So it will be a good option to contact, and you will actually get all the information on the website. So I'm sure that will be the best way to take forward that. I'm sure Dr. Anil will post the link for that as well, for the training and certification link for.
I'm sharing.
Thank you, Dr. Anil. What is the name of the certification? The name of the certification is ML Specialty with AWS. Keep guessing, Rohit. Keep guessing. Well, how do you define a level for data quality? So data quality level can never be defined as such, because there are no specific levels on that. It totally is very much application specific. Sometimes I have seen data, trust me, I've seen data where the data quality was so bad, but we did not have any option for that. You have to work on what you get. All you could do is try to improve it on your best, but there are some constraints always. You cannot always maneuver the data, you cannot always change the data, there are restrictions. So when you will be going on your machine learning journey in the real time, you will be seeing that there are several restrictions in the most of the steps. So you have to pass away those and make sure you reach the right path. And for that, you need to understand every aspect of each and every step. Once you understand the aspect and the basic concept why that particular step is there, you will be able to pass through all the hurdles. Okay, so yeah, definitely Dr. Anna will be doing that for you. Can you provide us some study material on ML as a subset of AI? Yes, definitely. I mean, if you will go to the ML website, there you do have AWS ML website. You do have several things over there. So if you go there, let's see the developer resources, getting started. So you see, I'm going to get a started guide here. That's right. This is absolutely public domain. So how do you get started? What is the SageMaker Studio? Here we are. This is also a very nice thing if you ever want to work on it. So you get everything right here. How do you create managing workflows, building models? You get everything. Okay. What is machine learning? And if you, so this is how machine learning with SageMaker will, this actually explains the whole process what we just discussed. This is actually the whole process which we discussed right away. Okay, for your, I'll just post this link for you guys in case you really want to work on this. I'm sorry for this. Let me just go back and pause this so that Any more question, guys?